Hello everyone, Vanakkam, Namaste and welcome to Problem Solving for Effective Mathematics Teaching and Learning. This is Lesson 6. I am Dr. Jayanti from Experiential Math Solutions. In this video, I am going to share some ideas on introducing mathematical investigations to arouse students' interest and to develop their mathematical thinking. What is a mathematical investigation? It's a tool to teach mathematics as it stimulates students' interest in math. It enhances students' thinking as they need to think of ways to solve problems. They cannot follow any procedures learned earlier. As students need to report their findings, investigations develop students' communication skills as well. Investigations should be an exploratory task, not just any questions, where students can plug in some numbers in a formula. Sometimes they need to derive a formula. When we assign investigations for higher level students, we can ask them to generalize the results. As students need to report their thinking process, how they derive the results, they develop metacognition, thinking about their thinking process. Hence, the process is more important than the final answer. We can give even younger students investigations. We can ask students to investigate mathematicians' simple discoveries. For example, Charles Dodson, 19th century English mathematician who is famously known as Lewis Carroll, the author of Alice in Wonderland, claimed that double the sum of two square numbers can be expressed as the sum of two square numbers. We can ask students to write some square numbers, all the square numbers from 1, 1, 4, 9, 16 and so on, and ask them to try whether it is always true using different square numbers. For example, here we have taken two square numbers, 4 and 16. Twice the sum of 4 and 16 will give 40. 40 can be expressed as the sum of 36 and 4. Similarly, if they take twice the sum of 1 squared plus 7 squared, 1 and 49, 1 plus 49 times 2, which will give 100. 100 can be expressed as the sum of 64 and 36. We can ask the students to prove it algebraically if they have learned the expansion of a plus b the whole squared and a minus b the whole squared. We can give students a scenario and ask students some questions based on that scenario. For example, Suresh and Ramesh are running a 25-kilometer race. Suresh runs every day 10 km. Ramesh increases his running distance every day by 1 km from 1 km. For example, first day he runs 1 km, second day 2 km, third day 3 km and so on. Based on this scenario, we ask some questions. Will Suresh and Ramesh meet in the first 10 days? Will Suresh and Ramesh ever meet? And we ask them to explain their answer. They cannot just say yes or no. Students have to find the distance Ramesh will run in the first 10 days and Suresh will run in the first 10 days. And based on that, they can find that Ramesh will run 1 plus 2 plus 3 plus up to 10, which is 55 kilometer, whereas Suresh will run 100 kilometer, so they will not meet. It's not possible for them to meet in the first 10 days. This is for the first question. But the second one is, will they ever meet? So let them find. Every student will find differently. Okay, maybe student can find 11th day, 12th day, 13th day, and so on. Or randomly they can find how much distance Ramesh would have run in 20 days, and Suresh will travel only 200 kilometer. So again, they have to adjust the days and find out how far Ramesh can run in 19 days, and then they can find out that they will meet. So every student may find different strategy. They may adapt a different strategy, but they can find that they will meet at 190 kilometer after 19 days. So the process is very important than just the final answer. Students should explain how they are finding the answer. That is very important. Students may be knowing the chessboard. So we will ask them to find the number of squares in a chessboard. Chessboard is an 8 by 8 square. So students normally will shout the answer as 64 or 65. 64 smaller squares and the bigger square 165. But we'll tell them that they have to find all the squares. So we have to think a little bit. Both are wrong. So you have to think more carefully. So we'll ask them, okay, let us find the total number of squares in 6 by 6 or 5 by 5 square. They can ask them to follow systematically. In 1 by 1 square, there is only 1. In 2 by 2, there will be 4 plus 1. In 3 by 3 squares, there will be 9 plus 4 plus 1. And in 4 by 4, there will be 16 1 by 1 square, and 9 2 by 2 squares, 4 3 by 3 squares, and 1 4 by 4 squares. And then let them find the pattern, and then they can extend the result to find the number of squares in a 8 by 8 square. That is the chessboard. Is there any relationship between Fibonacci numbers and Pythagorean triplets? Students might have learned about Fibonacci numbers and Pythagorean theorem, and they might have known Pythagorean triplets, but they might have not realized that there may be some connection between them. We can ask them to take any 4 consecutive Fibonacci numbers, say 1, 2, 3, and 5. Find the product of the first of these 4 numbers, the first and fourth number. One times 5 gives 5, and twice the product of the second and third number. 2 times 2 times 3 is equal to 12. Now 5 is one of the sides of the right angle triangle, and 12 forms another side of the right angle triangle. Then what will be the hypotenuse of this right angle triangle? Root of 5 squared plus 12 squared, which will be 13. Is 13 a Fibonacci number? Yes, it is the 7th Fibonacci number. Now let us take another 4 consecutive Fibonacci numbers. 3, 5, 8 and 13. Like before, we will find the product of first and fourth number, Fibonacci number. 3 times 13, 39. It forms one of the sides of the right angle triangle. Let us find 2 times 5 times 8, which is 80. It forms another side of the right angle triangle, 80. And what is root of 39 squared plus 80 squared? That is the hypotenuse. That is 89. Is 89 a Fibonacci number? Yes, it is the 11th Fibonacci number. When we use 1, 2, 3, 5, which means Fibonacci number 2, 3, 4 and 5 to form the arms of the right angle triangle, then the hypotenuse is the 7th Fibonacci number. We generated 39 and 80 from the 4 Fibonacci number 3, 5, 8, 13, Fibonacci number 4, 5, 6 and 7. Then we found that 89 is the hypotenuse, which is the 11th Fibonacci number. Students can find the connection now. Now we are using 2, 3, 5, 8 as the 4 consecutive Fibonacci numbers to form the sides of right angle triangle. Can you guess which Fibonacci number will be the hypotenuse of this right angle triangle? Yes, it should be 9th Fibonacci number, which is 34. Let us check. 2 times 8, 16. 2 times 3 times 5, 30. Let us find the hypotenuse of this right angle triangle using Pythagoras theorem. It is 34. So instead of asking students to learn Fibonacci numbers and Pythagorean triplets separately, normally we do that, but we can arouse students' interest in mathematics by asking them to find the connection between these two topics. When we use 4 consecutive Fibonacci numbers, say fn, fn plus 1, fn plus 2, fn plus 3, to form the sides of a right angle triangle, we know that f2n plus 3 will become the hypotenuse of this right angle triangle. We can ask higher form students to prove this result. It will be challenging, but students will find it very rewarding. Hope you will try these kind of questions called investigations with your students or children, and please write to us your feedback in the comment box. Please stay connected with us by subscribing our channel Experiential Math Solutions. I am Dr. Jayanti from Experiential Math Solutions signing off. Stay healthy. Goodbye and thank you for watching.